It is an interesting problem, and the question asks for finding the number of solution of this equation. You pause the video and try to think for a moment before you hit the solution. So here we go. Now the moment I look at the question, it feels like again we have two spaces, and which is 2 to the power x exponential, and 4 to the power x is roughly 2 raised to the power x whole square, and we have logarithmic spaces. So might be some of you might think of, like relating 2 to power x minus 1 with the inverse function 1 plus root x or something like that. What I mean is maybe we are getting a hint of 2 to power x minus 1 is y. So 2 to power x is y plus 1. So x can be written as log base 2 y plus 1. So finding inverse of this is actually not working because this quantity is not directly inverse of this expression, right? What if I take 2 raised to the power x minus 1 whole square as y? So in that case I'll get plus minus root y, and let's say if I take one branch, because for invertible function the function must be a bijection, so that gives 2 to the power x as 1 plus root y, and x is log base 2 1 plus root y. Yeah, now it makes sense, because if I take this as some function, so this quantity is nothing but its inverse, and you know the solution of f equals f inverse if a function is strictly increasing or increasing. In a loose sense, it lies on y equal to x line. If it is decreasing, then we can't comment, okay? And of course the solution will lie on y equal to minus x line, provided the function is continuous. So this idea of relating with f and f inverse doesn't seem to work very nicely over here. So what is the other way around? So now what we can do at least is we can, like put similar species on one side. Formation in mind, we can clearly see this can be written in nicer way, because we have 2 raised to the power 2 raised to the power x minus 1 whole square plus 2x minus 1 whole square. This quantity can be written as 2 raised to the power x whole square minus 2ab into 1. So I'll add 1 and subtract 1. So that gives us x plus 1 plus x. Now it's not very difficult to analyze the LHS function. Okay, so if I call this function f of x as 2 raised to the power 2x minus 1 whole square plus 2 to the power x minus 1 whole square minus 1, we can see the nature of this function, right? So roughly if I'll try to plot this function at x equals 0, you can clearly see at x equals 0 is going to be 0. Since 2 to the power x minus 1 is a concave up function, because its double derivative is going to be positive, so the rate of change of slope will be increasing, is positive. So if initially slope is, let's say, 1, then after some time slope becomes 1.5, then 2.5, psi double dash is 0. So function will behave like that, right? So in that sense this will also be concave up. Nature wise this is concave up, and minus 1 will not take away anything because you are taking away constant. So overall I can tell f double dash x will definitely will be positive here, right, for all x greater than or equal to 0. We are interested for non-negative x because of the domain restriction of root x over here, right? So we know roughly the nature of LHS is going to be like this. RHS, we are having root x plus log 2 1 plus root x. Let's call it again phi. Nature of phi, we can clearly see root x is concave down, and moreover nature of 1 plus root x will be same concave down, and log is concave down expression, right? Because log nature will also be something like this. So even for all positive input, its nature wise this. So this guy is behaving in a concave down manner. This is also concave down manner, so their addition is definitely concave down, which you can find by taking again double derivative of x, and that will be less than 0 for all x greater than or equal to 0, right? So this can be done either with second derivative or very fast with the philosophy of these smaller chunks, because here both of them is trying to support each other. So now with this two logic we are able to kill the question. This two sample logic we can easily kill the question, because LHS, as you can clearly see, is, let's say, psi x, and RHS is phi x. So it's amount to just finding number of intersection of these points, and since psi 0 is 0, and it's concave up from x greater than or equal to 0. Of course, we're interested. Next is phi of x. So this is of psi of x, and phi of x is going to be concave down. And fortunately, phi of 0 is 0, that we can check. At x0 it will die, x0 log 1 is 0. So we'll have one point of intersection as 0 and another point of intersection as alpha. And that's the only 2 point of intersection that we got. And the number of solution for this equation is 2. In fact, you can find the value of alpha here, luckily, because you can clearly see. In fact, you can find the value of alpha here because in the original equation, you can see x equals 1 is also working. So in fact, the solutions of this equation and the only solution is 0 and 1. So I hope you understood how to realize the question. Not only based on first derivative, but also sometimes second derivative test will be helpful to understand the game.